Hi everyone, I am here to discuss on how a graph can be represented in Python. So graph is a nonlinear data structure, we all know that, and how that graph can be represented. Normally a graph can be represented in any of the ways like adjacency matrix, adjacency list, and edge list. A graph can be represented in any one of these three ways. Adjacency matrix, as we all know, it consumes uh, some, if n is number of vertices and m is number of edges, it consumes n multiplied by m memory. Adjacency list is ideal data structure or ideal way of representing a graph. So in this one, we will consider one node, for example, say 0, and associated vertices like 0 is connected to 1, 4. So this 1, 4 is attached to 0. So similarly, with 1, what are the adjacent vertices? 0, 4, 3, 2. So this is how we represent adjacency list, and this we will maintain for each and every vertex. Okay. Then what is edge list? Edge list is nothing but storing all the edges. Suppose there are m number of edges, we will store the source and destination of each and every edge. For example, 0, 4 is one edge, 0, 1 is one edge, 1, 3 is one edge, 1, 2 is one edge, 4, 3 is one edge, and so on. All these edges will be stored as it is. Okay, so out of all these three ways, using adjacency list is preferable. Okay, so in Python, how this can be represented? That is our concern here. So for this I wrote code. So there is a dictionary data structure in Python using which we can efficiently represent graph, and the graph representation I am going to consider is adjacency list. Now let us see how this adjacency list representation of a graph can be implemented in Python. You see this one. Representing a graph using dictionary in Python. So this is very much similar to adjacency list representation of the graph. Initially we assume one dictionary graph. A graph is created and graph is in the form of dictionary here. Read number of vertices. In this case, in this graph, how many vertices are there? 5 vertices are there. 0, 1, 2, 3, 4. Read that number. Store it in the variable v. For I in range v, for each and every vertex, initialize graph.setDefault I, empty list. Normally, while working with dictionaries, dictionaries are treated like key value pair. So in most of the cases, we consider one value per key. In some cases, we may need to have multiple values per key. So in that case, we have to do this initialization. Then the value of each key will be treated as a list. Okay, so this will create a dictionary like graph equal to 0 colon 1 empty list, 1 colon 1 empty list, 2 colon empty list, 3 colon empty list, 4 colon empty list. This will be created with this statement. So initially we are making it a list. The value is a list. Okay, this is very important step. Then read the edges one after the other. What are the edges here? So we have the edges 0, 1, 1, 2, 1 3 0 4 4 3 and 3 4 1 4. How many edges are there? 1 2 3 4 5 6 7. There are 7 edges. Read them one after the other. How many edges are there? 7. Read them one after the other. How do you read? Source followed by destination. For example, 0 1 is one edge. 0 1 is one edge. How do you read it? 0 space 1. Like this you will be reading all the 7 edges. We need not mention priorly that this many number of edges are there. So we can use one unconditional while statement, while true, and read source and destination of each edge. Then read them as a list of strings and then convert them to integer. Or else we can store that as string itself. Okay. So here I am converting that to integer, and then that is stored in the list, and the first value of that list is S, second value of that list will be D. And when we will stop this input process, when source is given as -1 and destination is given as -1, then we will stop. Whenever we are using one unconditional loops like while true, we must be very careful where to stop. We must explicitly mention we have to stop at some point. Okay, so that stopping point here is when S is given as -1 and D is given as -1, we have to break. Then as this is undirected graph, if it is undirected graph, if you consider 0 1 as one edge, 1 0 is also an edge. That means we can go from 0 to 1 as well as 1 to 0. Okay, so that's why I am writing two statements here. Graph of S dot append D. What does this mean? S will be taken as key and its value will be considered as destination. So as we have already created one empty list as value, then this D will go into that list. Next, graph of D dot append S. So as I mentioned here, if 0 1 is considered as one edge, automatically 1 0 is also an edge. Why? Because this is undirected graph. If it is directed graph, we will strictly follow as per the edges given. Okay, then the graph is print the graph. So the adjacency list representation of the graph will be printed. Okay, so this is how we have to represent graphs in Python. And adjacency list is the ideal way of representing a graph, and that can be easily implemented using dictionary in Python. Okay, so once we get command over this one, we can go for breadth first search and then depth first search, breadth first traversal, depth first traversal, and we can do several manipulations on this graph. Okay, now let us quickly run this one. So first I will note down the edges here. What are the edges given? 0 1, 4 1 is given, 1 3, 1 2, 3 2, 3 2, and 1 4 is also there. 4 1 is there means 1 4 is also there. So I will be entering all these edges. How many edges are there? 1 2 3 4 5 6. 1 2 3 2, 0 1, 0 4, yeah, 0 4 I missed. 0 1 is one edge, 0 4 is one edge, okay, 4 1 is one edge, 4 3 is one edge, yeah, there are totally 7 edges. Now let me run this Python code with these given vertices and edges. So this is the code I have written in Python. Let me run this code. How many number of vertices are there? 5 vertices are there, 0 1 2 3 4. Okay, I am giving that 5. Then we have to enter the edges one after the other. 0 1 is one edge, 4 1 is one edge,